Hello, hello everyone. Hello, hello, hello. Let's wait 1 2 minute for people to join. Okay. Till then, you can tell me in the chat that in which year currently you are and how many of you attended the day one and day two session. Hello Aryan. Hello San. Good evening Arvind. Yes. Good evening. Good evening. Good evening. Second year, first year, attended all session. Great. 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 And other, from which year of your college and which branch? Just we are waiting 1 2 minute for other peoples to join the session. Yes, yes, Dinesh. Hello, Dinesh. San, third year attend all the session. Nice, nice, nice. First year, first year. I can see a lot of freshers, lot of first year students. Second year, okay, okay. Vivek is from third year. Okay, okay, okay. So I think we should begin with the session. Okay. Just let me know in the chat my video and audio is clear to all of you. Let me know in the chat. My video and audio is clear and I'm also sharing my screen. Okay. I've shared my screen. Let me know that my voice, audio and my screen is visible. All thing are clear. Yes, yes, yes. Okay. Okay. So let's start with the day 3. So what is the agenda for day 3? So today we are going to discuss about stacks. Okay. So we will discuss about stack, how why we need to use stacks. Okay. We will study the methods of stack, all the methods, important methods in stack. Then we will move forward to queues. After queues, in queues we also discuss about methods and why we need to use queue actually. Okay. We will solve some problem using stack and queues. Okay. After stack and queues, we are going to discuss one of the most important topic for recursion. Okay, one of the most important topic for today, which is recursion. We are going to discuss like how actually recursion works behind the scenes. Okay, and then we are going to, if we have time in the end, after discussing some problems, we are also going to discuss how to convert a recursion solution in a dp solution, in a dynamic programming solution. Okay, we will try to convert if we have time in the end, after covering some problems using recursions. Okay, okay, how many of you already studied the recursion? Somebody is saying screen is not visible. Is my screen is visible to all of you? Yes, audible, visible. Uh, Sriram is saying that screen is not visible. Please let me know my screen is visible to all of you. Yes, yes, yes. One more thing, you guys can mark your attendance using the link provided in the description. Okay, you guys can just mark your attendance using the link provided in the description. Okay, and about the certificate, you will get the certificate after attending all these 3 sessions and marking your attendance. Okay, don't worry about the certificates; you will get that. Okay, let's start with the topic. Okay, so what we are going to start with, we are going to start with stack. Okay, so what is a stack? Stack is a basically a data structure which is based on LIFO principle. What is LIFO principle? Last in, first out. Okay, let's discuss more about stacks. Let's take an example. Let's suppose you have some books. Okay, let's suppose you have some books lying on a table. Okay, And this is one second number book, and here it is third number. Now you come here, and what all the things you can do with these books. First of all, let's suppose you have a new book with you. Let's suppose you have a new book with you. Now, what you can do? You can put this book at the top of this stack. Okay, let's suppose you put this book at the top of this stack. Now, new book will come here. Okay, one thing you can do is put at the top or adding element at the top. Okay, the second thing you can do, let's suppose you need some book. Now, which book you can get from this stack? The topmost book. The topmost book will be get first if you want to get any book out of this stack. Okay, let's suppose you want to remove any book. If suppose you want to remove any book out of this stack, so you will get the first, which is topmost element or topmost book. Okay, let's see the third operation you can perform over these stack of book. Let's suppose you just want to see which book is lying on the top. If you want to see which book is lying on the top, you can get the topmost book. Okay, now you are not removing this topmost book. Okay, understood. So similarly, the stack the stack data structure work on similar principle. Okay, let's talk about stack now. Let's talk about stack. You can assume stack as a container in which we put elements. Let's suppose first of all we have a operation for adding an element. For adding an element for adding element, we have post x, this method. If let's suppose we post 4 in this stack, now 4 will come here. Okay, now 4 will come here. Again, let's suppose I post 3. Now where 3 will go? 3 will go at the top of this stack, means 3 will come here. Now try to remove some element from stack. So for removing any element, we have a method which is pop. Okay, uh, if I do pop operation, what we will get? We will get the topmost element, which is 3. Okay, we will get 3 here. Now if I again try to pop this element, if I again call pop method, now I will get the topmost element is 4. Okay, if you can observe the element which I am putting at the end, if I putting at the end, let's suppose I am putting 5 at the end, which will we get out of this stack at first? Okay, so what is the principle? Says LIFO, means last in first out. The element which is adding in the last will be getting out of this stack first. Okay, got it, everything is clear. Let me know in the chat if you have any doubt till here. Yes, okay, any doubt till here? Everyone, please let me know in the chat if you have any doubt. Okay, so let's try to code this. Okay, let's try to code. So first of all, okay, let's try to code. First of all, we will initialize a stack. How to initialize a stack? We'll simply write stack. We'll simply write stack, and then the data type of this, the container data type we will write. Let's suppose we are using an integer data type here. and we will providing the name of the stack, let's suppose st. Okay, and then this. Okay, we have declared an stack. Okay, let's try to put some element into stack. Let's try to put dot push dot push 5. So I have put element 5 in the stack. Okay, now let's try to put some more element st dot push 2. Okay, st dot push 7. Okay, if I try to pop out any element, let's suppose I write cout st dot pop. Okay, what we will get in the output? What we will get in the output? Let me know in the chat. What we will get in the output? What should be output of this? Yes, what should be output of this? 7, 7. Yes, 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 correct. I'm doing, I am first of all putting 5 here, then I am putting 2 here. After 2 I am putting 7, and if I am using pop method, so what will come out? 7 will come out. Okay, let's suppose I just want to check which element is present at the top. We can use a method which is called, we can use a method which is called top. Okay, it will simply tell which element is present at the top. It won't remove the element. So if I use st dot top, okay, it will return the topmost element of the stack, which is also in this case 7. And we also have a method. We also have a method to check the current size of stack, which is st dot size. Okay, if we use st dot size, we can check the size of this stack. Okay, everything is clear? Everything is clear? Everything is clear till here? Let's try to print the topmost element. Okay, let's try to print the topmost element. Cout st dot top. Okay, let's try to call this. We got 7 here. Let's suppose I call pop here. Let's suppose I call pop here. Again we will get 7. Okay, uh, what we are doing any mistake here? Let's try to just trace a second. St dot, okay, st dot pop, and let's try to print this. What we will get? Just wait a second. Okay, it will just print. Okay, let's suppose I write st dot pop here. Then I will try to see out st dot top. Okay, if I write this, what I will get? Uh, by it's showing some error. I've included. Okay, in pop. Okay, just wait a second. if I write st dot pop, okay, let's try to run this code first. Is this giving any error? No, it's not giving any error. Let's try to print C out. Okay, okay. It is giving here 2. So in this line, what we have done, we have pop out the topmost element which is 7. Okay. Now what we are doing here, we are checking which is topmost element now. So what we have done earlier, we have pushed the 5 here, then 2 here, then 7 here. Now in this line, we have pop out 7. So the topmost element will become 2. And here we are checking which is at the topmost element, and it is given 2. Okay, got it, got it. Okay, okay, clear. Let's try to solve a problem around this. Okay, let's try to solve a GFG problem. Okay, okay, we have a problem in which we are going to implement a stack using a array. Okay, so in this problem we have given an array using which we have to implement this push and pop methods. Okay, okay. So what we can do, let's suppose this is an array. Okay, we have given an array of size 1000, means array is very big, so we don't need to worry about the size of this array. Okay, we have given an array and top value initially which is equals to 0. What top says means top says the top is an index which says the topmost element. Okay, it is an index for the topmost element for stack. Okay, in the beginning a stack is empty, so top value will be 0, sorry, top value will be -1. Okay, so here we have initialized top with -1 and then an array of size 1000. So we need to implement a stack using array. So how we can solve this problem? Let's try to solve this problem. So what we have given an array, and initially an array is given and a top pointer which is initially at -1. Okay, let's write the index 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so now we will try to implement the first function, that is push, and it will take an integer, let's suppose x. Now where we will add this x in this array? Let me know in the chat where we will add this x in the array. Where we will add? Yes, where we can add this x element in this array. Yes, to the last index. Somebody is saying at the end index. So we have given a, see, in the problem we have given a pointer which is top is equals to -1. Means first of all, we every time add a element at top. This is we know about stack. So we will try to add around this top element. Okay, top is given -1. So we'll try to increase top. First of all, we will increase top. Top is equals to top plus 1 means it will be equal to, here I am writing for first case, it will be equal to 0. So I will add the first element at 0th index. Okay, what I will do, array of array of top is equals to x. Okay, now what it says, now top comes, see, top is equals to 1, and for stack we know what top says. Top says the topmost element. For now the topmost element is x only. Okay, now try to, for this push method we will try to implement pop method. If both the function works fine with each other, then our work is done. Okay, we'll try to implement the pop function. What will pop function will return? It will return an integer value. And if I write a pop function, what should this function do? What should this function do? Yes, what we need to write in this pop method for implementing this stack? See, we have studied that every time the element at top index will be removed. So we need to do this only. Okay, so top element, which is top element? For now, top is equals to 1. For now, top is equals to 1. Let's suppose, let's take an example. Let's suppose if I added some values. Mm, okay, let's suppose I called this push method for 2, then top will come here. Again I added push, I called push for 3. Now what will happen? Top, first of all, top will increase. Top will go here and I will add element 3 here. And if I again call push for 4, then this top element will increment. Now it will come here at this 2 index, and the element will be added here. Now we know that the element which is added in the last should be removed when I call this pop method. Means the element present over this top index. So I will simply, I need to return the element present on this top element, on this top index. Okay, so what I need to do, I need to return I need to return array of top. But but there is a problem. There is a problem. So let's see what is the problem here. Now if I remove, if I our top is here and I return this, I need to shift back the top, because now my top element should be 3, because 4 is already removed. Okay, getting my point? Because 4 is already removed, we need to shift back top to 3. So if I write after return, so this line won't work, because the execution will completed here only. So I need to do this top minus minus before this return statement. Okay, let's suppose I write top minus minus before this return statement, then the exact value at top index will not be returned here. So what I need to do is, in this pop method, first of all, I will store the value in some variable. I will store the value of top and decrement the top. It means after removing this index, a top will reduce minus 1 index. Okay, so I will simply return here, return array of x. Okay, clear? Clear? This is clear to everyone? This is clear to everyone? Let me know in the chat. Any doubt till here? Okay. Yes, sir. Clear. Yeah. Clear. 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 Okay. Okay. Great. So now there is one more case left here in this pop function, in this pop method. Anybody can tell which case is left till here? What is left? In this, we need to write one more line in this pop method. What is that line? Anybody? We need to add a base case. Can anyone think of that base case? For that, this method won't work. Yes? Can anyone tell? Let's suppose in the beginning, in the beginning, we don't have. Yes, yes, yes. Yes, correct. Somebody says that when there are no element. Yes, correct, correct. So in the beginning, if we don't have any element, if we don't have any element, just a second. Okay. In the beginning, we don't have any element. So our top is pointing to -1. So can we pop any element out of this array if we don't have any element? So we just write a base case for this. I'm writing here that base case. If if uh, if let's suppose top is equals to -1, just return -1. Okay, this is the base case for the empty stack. Okay, if there is no element present in the stack, we will directly return -1. Okay, let's try to code this. Okay, so for the push function, what we'll simply do, first of all, we'll simply increment the value of top plus plus, and the second thing we will do, simply add the element at top index. Okay, we'll add this x value at the top index. Okay, anything we need to do other than this? No. Let's try to implement this pop method. In this pop method, we need to check the first of all base condition. If top equals to -1, just return -1. Okay, just return -1. And the next thing we need to do is, the next thing, we'll store the value of top int x equals to top, and the second thing, will decrement the top, and return the value of array at x. Okay, clear? Clear? Let me know in the chat if this is clear. Yes, clear. Let's try to run this code. Okay, let's try to submit. Okay, our code submitted successfully. Okay, got it? Everything is clear? Any doubt till here? Any doubt in stack? You guys are not responding in the chat. Please respond in the chat. Everything is clear? Any doubt? Yes. Okay, okay, clear, clear, clear. Okay, let's move forward. Let's study about Q. Okay, so Q. What is a queue? Queue is simply, we can, okay, let me open Blackboard again. We can think queue. Let's suppose you use, let's suppose you went to SBI bank. Okay, let's suppose you went to SBI bank, and here is a cash deposit counter. Okay, and here is a queue of person who want to deposit cash. Okay, now these are the persons who want to deposit their money in the bank. And if you went to this bank, where you will join the queue? Let's suppose first of all you will try to join here, but these people won't allow you to join here. So you need to go here and join this queue here. And the first person which will come out of this queue is this person, which will come the first, which has come the first will go out first. So it will, like, if I say Q is a data structure which is based on FIFO principle, means first in first out. जो पहले आएगा पहले पाएगा. ओके, जो पहले आया था क्यू में वो सबसे पहले इस क्यू से निकलेगा. Simply, so basically we can assume this data structure as an array in which you will add element. Let's suppose you are adding an element 4, so you will add here 4, and then let's suppose you are adding 5, so you will add 5 here. Now let's suppose you are adding 3, so 3 will be added here at the back side of this queue. Okay, let's suppose you are trying to remove an element, so the element which come first, which element come first? 4. So 4 will be removed out of this queue. Okay, let's discuss the operation we can perform over queue. Similarly, we have these kind of, like, we can pop from queue. We have pop operation. Okay, we have push operation for adding an element. Okay, for adding an element we have push app operation. Similarly, for popping out any element we have pop operation. And for checking the size we have size, we can use dot size. Okay, one more thing, in stack we have top. Okay, because we are getting the topmost element from stack. But in queues we have front, like the element which is present at the front. Okay, if we use front, we'll get the element which is present over the front element of this queue, means the element which came first. Okay, okay, this is how a queue works. Okay, let's try to implement queue also, so that you have good understanding about the methods, how they are actually implemented. Okay, so now we will try to implement the push and pop methods in queue. And in this we have given, similarly we have given an array. Okay, we have given an array, and in this case we have given two pointers, a front pointer and a rear pointer. Why we are given two pointers? Because if we are going to add an element, we are going to add around rear. Okay, on the rear index. And if we want to like extract any element from the this queue, we will extract from front. This is how we need to implement these methods. Okay, so let's discuss how we can implement these methods. So initially in this problem we have given an array, and the initial value of the rear is 0, and the another variable was front. Okay, and the front is also equals to 0. You can see they have initialized front and rear with 0 0. Okay, so now let's suppose we are implementing int, and let's suppose we are implementing the first function method, which is push. Okay, the if you can see the first, like uh, the first position in which front is equals to rear means there are no element present in the queue. Okay, let's suppose we are pushing an element x. So where we are going to push this element in this, let me also write indexes 0 1 2 3 4 5 6 and 7. Okay, so where we are going to add this x element. Yes, anybody? Let me know in the chat how we can implement this push method. See, we are given rear. See, in Q, we know the element is always added at the rear index. Okay, and the initially there is no element present over 0 index and rear value is equals to 0. So we will simply, what we will do, we will add array of rear equals to x. Okay, now one more thing we need to do. Now, let's suppose another element will come and now someone wants to add another element which is 5. So for that we need to increment rear for the next push. Okay, so we will simply increment our rear here. Okay, this is very simple. Now we'll talk about the pop method. Okay, I'll talk about the pop method. In the pop method, we know that the pop will happen from the front index. Okay, okay. Let's suppose I've pushed some elements 5 here, 4 here, 3 here, 2 here, and 1 here. Now our rear will come here because I know rear is always uh, at 1 plus index where I am going to add next element. Okay, here my rear is present and my front is present here initially. Okay, so I need to remove this element. I need to remove this element. Then where the front will go? Front should go at this element, means this index. So it means front will be equal to front plus plus. Okay, and I need to return this element. Got it? So what I will do, similarly, I will save the value of front here, and one more thing, I will increment the value of front plus plus, and return, return array of x. Okay, got it? Here also we have a base condition when no element is present. What was that base condition? It was when front is equals to rear. When front is equals to rear, it means there is no element present in between front and rear. Okay. In this case, we will return -1. Okay, got it? Got it? Let me know in the chat if all clear. Everything is clear. If you guys have any doubt, please let me know in the chat. Hmm? Otherwise, we will move forward. Yes. Okay. Okay. Let's try to code this. Okay. For for pushing element, we need to just push the element at rear position. Okay. So we'll do array of rear is equals to x. Okay, and we will increment the value of rear. And in this pop method, what we will, first of all we will check if rear is equals to front, it means no element is present in the queue. Will simply return will simply uh, return return -1. Okay, else we will check at int x equal to, first of all we will store the index of front and increment the value of front. Okay, and at the end we will return value at x index, means array of x. Okay, okay, all clear. Ruchika is saying repeat once, repeat one. Okay, I'm repeating it once very quickly. Okay, so what we have given an array. Just wait a second. Okay, we have given an array in which we have given an array and two pointers, front and rear, and front and rear is initialized with zero value. So if we are going to push any element in queue, we know in queue we every time push a element at the rear position. So this rear pointer will deal with the push method. Okay, so initially there is no element present in the queue, so and rear is pointing to zero index. So we will simply add at zero index this value x. Okay, array of rear is equals to x. Now after some time, let's suppose someone again pushes an element, so for that we need to increment rear plus plus, so that after that it will go here. Let's suppose I add it at zero index. After pushing at zero index, I will shift a rear here, so that next time someone is pushing, so it will go to first index. Okay, so this is how I am implementing push method in this queue. Okay, let's talk about pop method. In pop method, for popping out any element out in queue, we note that we pop out element from the front. Okay, so and in the beginning, the front is at the zero index. Okay, so first of all we will store the value of front. Okay, let's suppose I am popping out, just wait a second. Initially front is here. Let's suppose I am popping an element out of this queue, so 5 should get out of this queue, so front should go to this index. Okay, so first of all I am storing the value of front and increasing front, so that it can point to this value. Okay, and in the end I am returning array of x, which is equals to 5. Okay, got it. So simply I have coded this only. Okay, all clear, all clear. Let me know in the chat all clear, so that we can move forward to one of the most important topic for today. Okay, clear, clear. Okay, okay. So just wait a second. Okay. So now we are going to discuss about recursion. Okay, this is one of the most important topic of data structure, because all the advanced algorithm and data structure we require knowledge of recursion. If we talk about graph, I know dynamic programming is only based on recursion only. Okay, so recursion is one of the most important topic of data structure, and it is quite difficult to understand. And if we see the definition of recursion, it says recursion is an programming technique where a function calls another function with same function definition. So okay, this is a definition of recursion. Let's understand recursion very simply with real life examples. Okay, try to understand recursion. So the definition says function calling another function, calling another function with same same function definition and parameters. Okay, let's understand this definition with some real life example. Let's suppose, just wait a second. Okay, let's suppose there are four friends. Let's suppose there are four friends A, B, C, and D. And all these friends are living 50 kilometers apart in a single line, in a straight line. Okay, now I given some books to person A and asked him, can you please give all these books to person D? I asked this person A, can you please give all these books to person D? I given these books to person A. Okay, if we can observe for A need to travel 150 kilometer to give all these books to D. Okay, so it is quite difficult for A to go 150 kilometers and give all these books for to D. Okay, so what A can simply do? A can simply give all these books to B and ask him, can you please give all these books to D? Our final output should be all books should reach 2% D. Okay, I've given initially all books to A and asked him, can you please give all these books to D? And for A it is quite difficult to go 150 kilometers, so he simply given all these books to person B and asked, can you please give all these books to D? Okay, and if we again see, for B, it is also quite difficult to go 100 kilometers. Now for A, it is 100 kilometers. Going 100 kilometers and giving to D all books, it is quite difficult for B also. So what we will do, we will simply give all these books to C and ask him, can you please give all these books to D? Okay, after when C receive all these books, for C it is 50 kilometers, so he will simply give all these books to D. Okay, okay, clear till here? Let's assume these A as functions. Let's assume all these person as functions. Let's suppose this is A function, and this is B function, and this is C function, and this is D function. Okay, what all these functions are doing? If we observe, they are doing the same work, going 50 kilometers, going 50 kilometers and giving all these books to another function. Got it? They are doing same work. Means if they are doing same work, it means function definition, function definition is same. For all these functions, the function definition is same. And if we can observe one more thing, what these functions are passing as parameter, they all are giving, this function is taking books as an parameter and passing books as an parameter. This also taking books as an parameter and passing to another function books as an parameter. So here we can also say parameter function parameters are same. Okay, if we can observe, first thing is this and second thing is, and if we can see the definition, it says function calling another function with same function definition and same parameters. Okay, definition is clear. So this is only recursion is this only. We'll understand more about recursion, how to approach every problem. All clear? All clear? All clear? Okay. Now we will understand. Now let's talk about this person D. Here we know that our task is completed. So D person should not need to pass all these books to any other person. So here we know a task is completed. Means we need to check every time is a task is completed or not. It means there is an if condition inside which we have some condition which is checking we need to call another function or not. This is be called a base case. Understood? This is what we call a base case because we know the person T should get all the books. Now we need not to call another function. So we'll stop calling another function. So in this case, this is base case. Understood what is base case? Understood? Okay. Now we will talk about this is first thing we need to check what is base case. Now second thing is this these all function are doing some work. Doing some work is going 50 kilometers, which is the easiest task that these function can perform. So we need to check the easiest work can be done. Okay, we need to check which is the easiest work a function can perform. For in this case, going 50 kilometers is the easiest task. Okay, so we have checked the base case. We have checked the easiest task that function can perform. Now the last thing, which is recursive call, which is a recursive call. Recursive call. Okay, now what is recursive call? After performing some work, this A function called this function B. This is only the recursive call. Here we need to call a here we need to call a function recursively. If you can find all these 3 points, you can solve any recursive problem. Okay, you can think of any problem in recursion by just thinking about these 3 points. Okay, everything is clear, crystal clear. Got it? Please let me know in the chat if you have any doubt. Yes, 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 yes. Are you guys enjoying the session? Please let me know. See, if you connect every data structure or algorithm with real life situation, you will get like you will learn more efficiently because you will learn them for a longer time period. Okay, you will understand everything if you connect every algorithm with some real life situations. Okay, okay, okay. Now let's discuss with some problems. Yes, we will solve a problem in the end on lead code or GFG also in recursion. Don't worry. Let's try to solve some basic problem first. Okay. So first problem is we need to just wait a second. I'm writing here. Okay. So we need to write a recursive function that takes an integer n as a function parameter and print all the numbers from n to 1. Okay. This is very basic problem. We just need to think about three things. First was first was a base condition. Second was easiest task that the function can perform, and the third thing is recursive call. Okay, in this problem we need to write a function which takes an integer n and print all the integer from n to 1. Let's suppose if n is equals to 5, then it should print 5, then 4, then 3, then 2, then 1. It should be printed. Okay, let's talk about the base case. Let's talk about base case. So can you observe what is the base case here? Yes, can you observe what is the base case here? Please let me know in the chat what is base case for this. Yes, please let me know in the chat. Yes, yes, yes. What will be the base case for this function? We can see here function is stop calling another recursive call. So somewhere here is the base case lies. Let me know in the chat what should be the base case. Please take one more class to take time complexity. For this, you can connect with Let's Upgrade team and can ask them. Okay. Yes, yes. Somebody is saying return f of n minus 1. Return 1 if 0. If let's suppose n equals to 0, n is equals to 0, we need to return 1. Are you saying this? No. See, what we can do, see, this function we are going to create is to just print the numbers. So the return type will be void. Okay. The return type will be void of this function. Let's suppose function name as, let's take function name as print print number. Okay, print number, and it is taking an integer n as an input. Now base case should be, let's suppose if n is equals to 0, I don't do anything. Okay, so what I will write, if n is equals to 0, I will simply return from here. Okay, this is the base case we can write. Okay, yes, yes, okay. We have thought of the base case which is equals to, if n is equals to 0, return from this function. We need not to do anything in this case. Now what is the easiest task that this function can perform? Which is the easiest task this function can perform? Let's suppose I call this function, let's suppose I call this function for 20. What is the easiest task this function should do? Yes, what should this function can do the easiest? It can simply print this number, print 20. See, I need to print 20 to 1, so first task is printing 20 only. Okay, the simplest task can be done is printing the number itself. Okay, I will write the easiest task it can do is print n, that is coming into input. Okay, I printed input, like printed n. Now what task is left? I need to print from n minus 1. Okay, so the task that is remaining is printing all the numbers from n minus 1. So I will call this function for n minus 1. Okay, I have thought of all these things, all these three conditions. Now we can solve this problem. Let's try to code. Let's try to code. Okay, let's try to code this function. Let's create a function first that is a void type because it is not returning anything, and I'm giving the name as print number. Okay, and it will take an integer as an input, int n. Okay, and now we need to write the base case first. I'm writing here base case base case. What will be the base case? If n equals to, if n equals to 0, I will simply return from here. I will simply return from here. And now the second task is the easiest task, easiest, easiest task that this function can perform. Okay. What is the easiest task? Just printing, just printing the number n. Okay. Just printing the number n. Now, the third thing is recursive call. Now, what is remaining to do? Now, printing the number from n minus 1 to 1 is remaining. So, I will call the function print number again here in this print number n minus 1. Okay, I will call for n minus 1 this function again. Okay, everything is clear. Let's try to call this function for print number, print number, print number 10. Okay, let's try to call this function for this. What what it should do? It should do, it should print all the numbers from 10 to 1. Let's try to run this code. If you can see, the numbers from 10 to 1 is printed. From 10 to 1 is printed. Okay, everything is clear. Let me know one thing. If I change one thing in this code, if I change this part from here to here, okay, what will be the output? What will be the output? Yes, 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 yes. What will be the output for this? Yes. What should be the output? I'm waiting for your answer in the chat. Siddhakar is saying 20. I have see. I have done some changes in the code. I have written this see out statement, printing statement uh, after this print number, this recursive call. What should be the output? See, in this case, in this case, output should be 1 to number n. We will discuss how this is happening. Let me try to run this code. In this case, numbers will print from 1 to 10. You can see the number printed here is 1 to 10. Okay, okay. Let's uh, think why it is happening. See, anybody knows how recursion works behind the scene? What it uses for working? Like it is calling another function. Now let's think. Okay, you know about call stack? You know about call stack? Do you guys know about call stack? Yes. See, this recursion function is executing with the help of a call stack. Okay, let's understand. I'm writing this as line 1 of this code and this as line 2 of this code. Okay, let's understand on blackboard. Okay, let's try to understand here. Okay, so what I am doing for, let's suppose I have called the function 5 for 5. What the base case was, if n is equals to 0, just return. Okay, this was base case, return. And I have returned the recursive call first. So function, I'm calling the function as n minus 1 here. This is first line of code. Okay, and second line was printing printing the number itself. Okay, if I call this function for 5, what happens in the call stack? See, we have studied about stack. Okay, so in the stack, the code which is currently executing is at the top of the stack. Okay, how recursion works behind the scene, we can see here. If suppose I called this function for n equals to 5, so this function 5 will come here. Okay, this function 5 will come here in the call stack at the top. Now, what will happen? It will check the the base case. Now, base case is not true. Now, it is calling another function. It is calling another function. So, for what it is calling? For n minus 1. Means it will call another function for n is equals to 4. Okay, for this function 5, the first line is executed. Okay, I am writing this as first and this is second line of execution. Okay, for this function 5, the first line is already executed and it has called function 4. Now function 4 again call function for 3. Okay, for this first line is also executed, it will call function 3 for printing 3 to 1. Okay, and for function 3, if it execute its first line, it will call for function 2. Okay, if it will call for function 2, and for function 2, if we execute the first line, it will call function 1. And if we execute the first line for function 1, it will call function of 0. Now if we can see, for function 0 means n is equals to 0, it will simply return. It will do nothing but return from here. Means if it is return, means we have we can remove this out of this stack. Now I have written function of 0 out of this stack. Now which is at the top of this stack? This is function 1. Okay, the function 1 is at the top of the stack, means the execution which is remaining for function 1 will run now. For function 1, we already run the first line of code. Now the second line is remaining for function 1, which says print the n. For function 1, n is equals to 1, it will simply print 1 here. Okay, okay, it will simply print 1 here. And after executing the second line, there is no line remaining for function 1, so it will go out of stack. Now if function 1 is go out of stack, now we have function 2 at the top of this stack. We have function for 2 at the top of stack, and we can see the first line of code for function 2 is already executed and the second line of code is remaining for execution, which is equals to print the number. Here I'm writing output of this code. Okay, we have printed one in earlier step. So in this case, if we execute the second line, we'll get output as 2, print 2. Okay, and for 2 also, the every line is executed, so function 2 will go out of stack. Okay, function 2 will go out of stack. Now function 3 is at the top and first line is already executed. If we run the second line of code, it will print 3. Okay, it will print 3, and for 3 all line are executed, so it will go out of stack. Now function 4 is at the top. It's at the top. So for 4 similarly we will run the second line, it will print 4. Okay, and function 4 will go out of stack, and at the end we have function 5. We have function 5 and first line is already executed, second line is print n. So we'll print 5 here. Okay, so this is how we are getting 1 to n in this case, because we are calling recursive function before the printing statement. And this is how recursion work behind the scenes. Okay, this is how exactly recursion works. Got it? Got it? Everything is clear? Please let me know in the chat if you have any doubt. Yes, yes. Lucas, I earlier worked at Geeks for Geeks and Coding Spoon. Yes. Any doubt? Please let me know in the chat if you have any doubt regarding this, or everything is clear. No, no, no. Okay. Payal, do you have any doubt or everything is clear? Yes. Okay. So I think everything is clear. So we can move forward for solving another problems. Okay. Let's try to solve another problem. Okay. Okay. We can solve this problem. Okay. For finding the nth Fibonacci number. Okay, if you guys know Fibonacci series, it starts from 1, sorry, 0, 1, 1, and 2, 3. It's like the first element of Fibonacci series, the first element of Fibonacci series is 0, and second element is 1. The second element is 1. Just wait a second. And the third element will be sum of previous two. The next element will be the sum of previous two element. So here the third element will be 1 plus 0 equal to 1, and this is if we find the here 1 plus 1 is equals to 2 and 2 plus 1 equals to 3. Okay, this is a Fibonacci series. So we need to find the nth number of nth number of Fibonacci series. ठीक है, nth number of Fibonacci series find करना है with the help of recursion. How we can think of this solution? So again we need to think about three things only. First was base case. First was base case, easiest task, and third was recursive call. Only these three things we need to think of to solve any problem. Recursive call. Okay, what is the base case? What is the base case? See, in Fibonacci series, we already know that first element is 0 and the second element is 1. Okay, if let's suppose someone says Fibo, let's suppose name of function as Fibo, and it takes an integer n, for which we need to return the nth Fibonacci number. Okay, if the value of n is equals to, let's suppose if the value of n is equals to 1, we simply return 0. Okay, if we have n is equals to 2, we'll simply return 1. These are the base case. Okay, what are the base case? That thing we already know is if if n equals to 0, if sorry, n is equals to 1, the first Fibonacci number is 0. If n is equals to 1, we will print or return, let's suppose we are returning some integer, return 0, and if it is equals to 2, we'll simply return 1. Okay, These are base cases. Now we will think about the easiest task that we can perform. See, we know the nth Fibonacci number will be sum of n minus 1th plus n minus 2. Okay. If we can get n minus 1th Fibonacci number and n minus 2th, we'll simply sum to these two elements and return this. Okay. What we can do, we can find this n minus 1th and n minus 2th and simply return the sum of these two elements. Means we need to do sum of these two elements. This is the easiest task we can perform. Okay. What are the recursive call? See, in this case, if we think about recursive call, see, we need to find n minus 1th number. So for n minus 1th number, we will call Fibo of n minus 1. And for n minus 2 Fibonacci number, we will call Fibo of n minus 2. These are recursive call, and the easiest task, we will sum these two and return. This is the easiest task this function can perform. Okay, got it. Let's try to code this. Let's try to code this. Then we will try to solve one more problem, which is very important. Okay, let's try to code this first. Okay, let's create another function which return an integer value, and let's take name as Fibo of int n. Int n. Now the base case was if n is equals to 1, we'll simply return 0 from here. Okay, and another base case was if n is equals to if n is equals to 2, we will simply return 1, because the first Fibonacci number is 0 and the second Fibonacci number is 1. Okay, now we need to find n minus 1th Fibonacci number. Let's store the n minus first Fibonacci number as a, and we will call Fibo for n minus 1. Okay, for n minus 1, and int b is equals to Fibo of n minus 2. Okay, if we got these two numbers, which are n minus 1th number or n minus 2th number, I will simply return a plus b. Anything else we need to do? See, these are base case. This is the base case. This is the base case here, and this is recursive call. We have written recursive call here, and this is we are adding these two numbers which we get from recursive case, which is the easiest task we have done, adding these two numbers and returning. Okay, easiest task that this function can perform. Okay, got it. Let's try to run this code. Okay, let's try to run this code. See out for Fibo of, let's suppose for 5 we call. If we call for Fibo 5 and we try to run this code, just comment this. We got 3. Okay, we got 3 here. Now the first Fibonacci number is 0, the second is 1, the sum of these two is 1, and 1 plus 1 is 2, 2 plus 1 is 3. This is first Fibonacci number, this is second, this is third, this is fourth, and this is fifth Fibonacci number, and we get the correct output here. Okay, if we call for any value, it will give us the nth Fibonacci number. This function will give us nth Fibonacci number. Everything is clear? Everything is clear? Everything is clear? Please let me know in the chat. Yes, sir. Yes, sir. Yes, sir. Okay, let's move forward to one more problem. See, this problem you can try by yourself. I'm not discussing this problem. Code for factorial of a number. This is very easy. And what we have done. Let's try to solve a problem on Geeks for Geeks. This is a kind easy but a tricky one. Okay, this is very easy but a little bit tricky. Okay, so what this problem says, we have given n number of stairs. We have given n number of stairs, and we need to find always we can go to the top of these stairs. Okay, and we can do two things. We can either climb one stair or two stair. Okay, we can either climb one stair or two stair. So what we can do, let's suppose we have five stairs. This is first stair, this is second stair, this is fourth stair, and this is fourth sorry, this is first stair, second stair, third stair, fourth stair, and this is fifth stair. Now you can climb either on this stair or this stair. Getting the problem? Like we can climb either one stair or two. Okay, we need to find all the possible number of ways to reach at this nth stair. Okay, let's try to think. If suppose you climb only one step at a time, so you can go 1 2 3 4 5 by climbing one step. This is one way. Okay, now you go two step here and two step here and one step here. So you go two. First of all, you go to second stair, then fourth stair, then fifth stair. So this is also a way, second way. Okay, now you can also think another ways to go. There is a lot of ways to climb in this way. Let's suppose you go here, then you go here, then you go here. So one, then three, then five. So this is another way. There's a lot of ways possible to climb this. Okay, so how we can approach this problem? बहुत interesting problem है. Okay, how we can approach this problem? Anybody? Problem is clear? First of all, let me know that problem is clear to everyone, and if you got any approach, please let me know. Yes, explain again. Okay, see, I'm explaining very quickly. So we have four stair in this case. One, two, three, four. We have four stair, and you can climb either one stair or two stair at once. Means you can climb one stair or you can directly climb onto second stair. This is how you can climb these stairs, and you need to find all the possible ways to reach at this fourth stair. So how can you climb all these stairs? Let's suppose you go to second stair first, then after going here you climb two stair again and go to fourth stair. So this is a way how you can climb these stairs. Again, let's suppose you climb only one. Okay, so how can you climb? You climb first stairs, then second stair, then third stair, then fourth stair. This is also one way. Okay, how can you can, let's think another approach. Let's think another case. Let's suppose you climb one here, then two here. Okay, so first of all you climb the first stair. After climbing first stair, you climb the third stair. So you go here, and after going here, you go to fourth stair. So one, three, four. Okay, this is another way. So you need to return all the possible number of possible way. So here one way is this, one way is this, one way is this. So how many total possible ways you can climb and go to the nth stair? You need to find this. Okay, okay. Now it is clear. Yes, everyone. Yes, 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 yes. Yes, everyone. Yes, sir, clear. Okay, okay, okay. So, can we think of any approach to solve this problem? Any approach? Okay, let me tell you. So, see, if there are four stairs, one, two, three, four, okay, and you need to reach here. Okay, on the fourth stair, if we talk about the fourth stair, from which stair you can reach the fourth stair? You need to reach the fourth stair either by this stair or this stair. There is no other way to reaching the fourth stair other than reaching from third stair or two stair. This is clear to everyone. You can reach this fourth stair because you can only climb one stair or two stair at once. So you can either go here to here or here to here. Means second to fourth or third to fourth. Okay, so this is how you can climb to fourth stair. So let's suppose if I find total number of ways to reaching this stair and get all these ways to reaching this stair and add all these ways. Let's suppose reaching this stair are A and reaching to this stair the ways are B. If I add A plus B, will I get the total ways to reach at the fourth stair? Got it? Got it? Yes? Yes? Clear? So what I need to do for nth stair, this is n minus 1 stair, this is n minus 2 stair. I need to find the base for n minus 1 and n minus 2 and I will simply add these to get the total base for nth stair. Okay, so for this I will simply add these two things and return the answer. Now what will be the base case? What will be the base case? Let's suppose this is first stair and this is second stair. For the first stair, how many ways there are to reach to first stair? There is only one way to reach this stair by climbing only one stair. Okay, so it means if n is equals to 1, I will return 1 from here because there is only one way to climb one stair. Okay, let's suppose n is equals to 2. Let's suppose if n is equals to 2, for this stair, I can either go this way or I can directly jump on the second stair. So there are only two ways possible for reaching the second stair. Okay, so for if n is equals to 2, we will return 2. So these are the base cases. Okay, so can you can you observe something? This is kind of similar problem like a Fibonacci series. Okay, why? Because we are for getting the nth answer, we are adding n minus 1th answer and n minus 2th answer. So in DSA, if you are solving problems, just figure out just observe the pattern of problems. Because if you are solving a new problem, it might be possibility that you already solved that problem in another way. Okay, this is a new problem, but you have already solved this for a Fibonacci series. Okay, you can observe you are adding n minus 1th answer with n minus 2th answer, but a little bit difference with the base case. Here you are returning for n equal to 1, for it is returning 1, and for n equal to 2, we are returning 2. Okay, got the approach? You got the approach? Please let me know in the chat. Please let me know in the chat if you got this approach. See, for solving this problem, we just need to write first base cases if n is equals to 1, will simply return 1 from here. Okay. And the second base case was, if n is equals to 2, we'll simply return 2 from here. Okay. And after this, we can simply find the answer for n minus 1. Okay. So I will call this function count base with n minus 1. Okay. And int b is equals to count count base with n minus 2. Okay. And in the end, I will simply return a plus b. Okay. But in this case, the problem will compile and run. Our code is completely correct, but it will not submit here. It won't be submit here. Let's try to compile and run first. Let's try to compile and run. It is like compile and run is done, but like our code is completely correct. There is nothing wrong in this code. But if I try to submit this code, it will give us runtime error. No, it will give, I think it will give us uh, call stack error. Call stack or is full something. Let's see. See, we got runtime error here. Anybody knows why we are getting this error? Our code is correct. Our code is correct, but still we are getting runtime error. Why we are getting runtime error? If I can take 10 minutes more, if anybody has an issue with that, please let me know in the chat so that I can explain this properly. Okay. We are getting runtime error here because this is the problem of recursive approach. Here comes the problem in the recursive approach. Now, can we discuss the problem here? Okay, let's open the blackboard first. Okay, now we will discuss what is the problem in recursive solution and why DP comes into picture. Dynamic programming comes into picture because of recursive problem. Because let's suppose I call function for 5 here, it will call two things. Like I'm for a, I'm calling the function for n minus 1, and for b I'm calling the function for n minus 2. These two recursive call are there in this function. So it will first call function function for 4. Okay, and it will call function for 3, and this function will call function 2, and this is the base case we know. If n is equals to 2, if n is equals to 2, we will simply return 2. So it will return 2 here. Okay, for this the the first case is completed for recursive call. Now it will call for function n minus 2, which is 1. Okay, this is also base case. For n equal to 1, we know we need to return 1 here. So it will return 1 here. It will return 1 here. Okay, it will return 1 here. So what this function will do, it will add all these left and right values and return to this function. Now it will return 2 plus 1 is equals to 3. Okay, for function 4, left call is done. Now it's time for right call. Okay, for function 4, the left call was n minus 1, right call will be n minus 2. Okay, so now we will call function for 2. Okay, now function for 2, this is base case. It will return 1 here. It will return 1 here. Okay, now this function will add these two values from all these two recursive calls and return 4 here. 3 plus 1 is equals to 4 here. Now if we see for this, if we see here, let me adjust this a little bit. Okay, let's try this one. Okay, it will call function, it will call function 3 because n minus 1 is called. Now n minus 2 will be called. Okay, now it will again call function, function for n minus 1 which is equal to n minus which is equal to function 2. Now if you can see, we already calculated function 2, function 3 and function 4 here. Okay, we already calculated value for function 3 and it is again calling the value, it is again calling the function for n is equals to 3. If we already calculate, so do we need to calculate it again? Do we need to calculate it again? So there is a wastage of recursion calls. A lot of recursive calls are happening there. If there is a big value, a lot of wastage of recursive call will happen here. So function 2 will again, like, it will directly return the value here. What it will return? It will return 2 here. It will call for function 1. Okay, so you can see a lot of times same function are calling. So this is the issue in recursion. So what we can do is simply, let's suppose, anyhow, if I first time calculated function 4 and I saved the value for function 4 in any data structure. Let's suppose for function 4 it is clear, it is returning a value 4. And for function 3, if I store for function 3, it is returning value 3. So if I strike, if any point where I need to calculate a value for function 3, I will directly return this value 3. So now we need not to call a lot of recursive calls. We need not to call not a lot of recursive functions. Got it? Got it? You got the problem here? What was the problem? Got it? Everything is clear? So we need to store the values for every time we are calling function. Okay, so what we will do here, we will create an array. Okay, what we will do, we will simply create an vector here in which we will store the answer. Okay, let's create an vector. Let's create an vector. Just wait a second. Okay, we will create an vector of data type. We will store answer as integer value. Okay, int, and let's name this vector as array is equals to vector of, okay, and let's pass the value. What we can take sizes. See here, n is between 1 to 44. Let's take size as 45. Okay, let's take the size as 45. See, in this vector, we are storing the answer for every n. Okay, so we are taking 45, this, that's why size. Okay, so at beginning, we are storing value as -1 here. Okay, so every time we are getting an answer, we will just store that answer in our vector. Okay, so we will here we get for n, answer for n will be array of n is equals, simply we will write a plus b. Okay, and after this we will simply return array of n here. Okay, we have just stored the answer we have got. Okay, and if starting we check if the answer is already present or not. Means I will check array of n, if it is equals to is not equals to -1, is not equals to -1, I will simply return array of n. Okay, so what is it is saying? It is saying if answer is present, we will directly return the answer. So we need not to call these recursive function again if we have already answer. So this is like dynamic programming. This is only dynamic programming. We have converted the recursive solution in a dynamic programming solution. Okay, got it? Got it. Please let me know in the chat. So we'll try to submit this code last time and we'll finish with the session. Okay, let's try to submit this code now. Now the code is submitted. Okay, just wait a second. Hello, hello. Let me know in the chat if you have any doubt. We have completed with the session. Okay, please let me know in the chat. Yes. So I think everything is clear. So we have done with the session. So thank you everyone for joining the session, and please everyone just mark your attendance and also provide your feedback. Okay, and you will get your certificate soon. Okay. Thank you everyone for joining the session.